When an air conditioning unit activates, you might notice the lights dimming briefly. This phenomenon occurs because the air conditioner's compressor motor requires a substantial amount of electrical current upon startup. This sudden surge of current draw can cause a temporary voltage drop within the electrical system. Think of it like this: if you have a pipe with water flowing through it and suddenly you open another valve requiring a large amount of water, the pressure in the pipe might drop momentarily, affecting other outlets. The severity of the dimming is influenced by several factors. Firstly, the size of the air conditioning unit plays a crucial role. A larger air conditioner with a more powerful compressor will naturally demand a greater amount of current, resulting in a more pronounced voltage drop and, consequently, more noticeable dimming of lights. Secondly, the condition of the electrical system is a significant factor. An aging or poorly maintained electrical system might have undersized wiring, loose connections, or corroded contacts. These issues can impede the flow of electricity and exacerbate the voltage drop when the air conditioner kicks on. Thirdly, the distance between the air conditioning unit and the lights is relevant. The farther the lights are from the air conditioner, the more resistance the electrical current encounters along the wiring. This increased resistance can contribute to a greater voltage drop at the lights, leading to more noticeable dimming. If the lights dim significantly when the air conditioner comes on, it is important to address the issue promptly. A substantial voltage drop is not only an annoyance but can also pose risks to other appliances and electronics connected to the electrical system. Prolonged exposure to low voltage can damage sensitive electronic components, reduce the lifespan of motors, and even create a fire hazard. It is advisable to consult a qualified electrician to inspect the electrical system and identify the underlying cause of the voltage drop. The electrician can assess the wiring, connections, and overall condition of the system to determine the appropriate course of action. There are several potential solutions to mitigate or eliminate the dimming of lights when the air conditioner starts. Firstly, installing a voltage regulator can help stabilize the voltage supplied to the lights and other sensitive equipment. A voltage regulator automatically compensates for voltage fluctuations, ensuring a consistent and stable voltage output, regardless of the load variations caused by the air conditioner. Secondly, upgrading the electrical system might be necessary if the existing wiring is inadequate or if there are other underlying issues. This could involve replacing undersized wiring with thicker gauge wires, upgrading the electrical panel to a higher capacity model, or adding dedicated circuits for the air conditioner and other high-demand appliances. Thirdly, relocating the air conditioning unit closer to the lights can help reduce the voltage drop caused by the distance and wiring resistance. If feasible, moving the air conditioner to a location closer to the main electrical panel or to a point where the lighting circuit originates can minimize the voltage drop at the lights. In addition to these solutions, there are other steps that can be taken to improve the overall efficiency and stability of the electrical system. Regularly inspecting and tightening electrical connections can help prevent voltage drops caused by loose or corroded connections. Using energy-efficient light bulbs, such as light-emitting diodes, also known as LED, can reduce the overall load on the electrical system and minimize the impact of the air conditioner's startup current. Furthermore, ensuring that the air conditioning unit is properly maintained and serviced can help it operate more efficiently and reduce its current draw. A well-maintained air conditioner will start more smoothly and draw less current than a neglected one. It's important to understand some of the underlying electrical principles. Voltage is electrical potential, the driving force that pushes current through a circuit. Current is the flow of electrical charge measured in amps. Resistance is the opposition to the flow of current measured in ohms. These three quantities are related by Ohm's law, which states that voltage equals current times resistance, or voltage equals current times resistance. When the air conditioner's compressor starts, it draws a large current. This increased current flow causes a voltage drop across the resistance at the wiring. The voltage drop is more pronounced when the wiring is undersized, the connections are loose, or the distance between the air conditioner and the lights is great. Voltage drop at the lights causes them to dim. The amount of dimming is proportional to the voltage drop. A large voltage drop will cause the lights to dim significantly, while a small voltage drop will cause them to dim only slightly. It is important to note that voltage drops are a normal part of electrical system operation. However, excessive voltage drops can be problematic. They can cause lights to dim, appliances to malfunction, and electrical equipment to overheat. The National Electrical Code, also known as NEC, specifies the maximum allowable voltage drop for branch circuits and feeders. A branch circuit is the wiring between the last overcurrent protection device, such as a circuit breaker, and the point of use, such as a light or an appliance. A feeder is the wiring between the service entrance and the branch circuits. According to NEC section 210.19, A1, the voltage drop on a branch circuit should not exceed 3% at the farthest outlet. According to NEC section 215.2, A1, the voltage drop on a feeder should not exceed 3%. The total voltage drop on a branch circuit and feeder combined should not exceed 5%. These voltage drop limits are intended to ensure that electrical equipment operates properly and safely. If the voltage drop exceeds these limits, it is important to take corrective action. This may involve upgrading the wiring, tightening connections, or relocating equipment. When evaluating voltage drop, several factors need consideration. Firstly, wire size is paramount. Thicker wires offer less resistance to current flow, reducing voltage drop. The appropriate wire size is determined by the ampacity of the circuit, which is the maximum current a wire can safely carry. NEC Table 310.15 B16 provides ampacity ratings for various wire sizes and insulation types. Secondly, wire length is a factor. Longer wire runs result in greater voltage drop due to the increased resistance. Therefore, it's crucial to minimize wire lengths whenever possible. Thirdly, the load on the circuit influences voltage drop. High loads, such as the startup current of an air conditioner, draw more current and cause a greater voltage drop. Calculating voltage drop involves using Ohm's law and considering the resistance of the wire. The voltage drop can be calculated using the formula voltage drop equals current times resistance. The resistance of the wire can be determined using wire resistance tables, which provide the resistance per unit length for different wire sizes and materials. For example, copper wire has a lower resistance than aluminum wire. It is always a good practice to consult a qualified electrician for any electrical work or concerns. They possess the knowledge, skills, and tools to diagnose and resolve electrical issues safely and effectively. They can also ensure that the electrical system complies with all applicable codes and regulations. In summary, the dimming of lights when an air conditioner starts is often caused by a voltage drop due to the air conditioner's high startup current. The severity of the dimming depends on factors such as the air conditioner size, the condition of the electrical system, and the distance between the air conditioner and the lights. Addressing significant dimming is important to protect appliances and electronics from potential damage. Solutions include installing a voltage regulator, upgrading the electrical system, or relocating the air conditioning unit. Consulting a qualified electrician is always recommended for any electrical work or concerns. Furthermore, understanding the basics of electrical principles such as voltage, current, resistance, and Ohm's law can help in troubleshooting and preventing electrical problems. Regular maintenance and inspections of the electrical system can also contribute to its efficiency, safety, and reliability. Understanding the power factor is also important for large inductive loads such as AC motors. The power factor is the ratio of real power kilowatts to apparent power kilovolt amps. An AC motor with a low power factor draws more current than an AC motor with a high power factor for the same amount of real power. Utilities often charge commercial customers for low power factor. Power factor correction can be achieved by adding capacitors to the electrical system. The capacitors provide reactive power, which reduces the amount of current drawn from the utility. There are several types of AC motors used in air conditioners, including induction motors and synchronous motors. Induction motors are the most common type of AC motor. They are simple, robust, and relatively inexpensive. Synchronous motors are more efficient than induction motors, but they are also more complex and expensive. The type of AC motor used in an air conditioner depends on the application. For example, a central air conditioner typically uses an induction motor, while a window air conditioner may use a synchronous motor. When an AC motor starts, it will draw lock rotor amps. This is much higher than the full load amps of the motor. It can be 6 to 8 times higher than the full load amps. This is why the lights dim when the AC motor starts. The locked rotor amps cause a voltage drop in the electrical system. Once the motor starts spinning, the current draw decreases. The voltage drop decreases and the lights go back to normal. Electrical codes set requirements for AC motor installation. NEC Article 430 covers motors, motor circuits, and controllers. It includes tables for motor full load amps. It specifies overcurrent protection requirements for motor circuits. It has requirements for motor disconnecting means. Understanding these NEC requirements is important for safe and reliable operation of AC motors. The NEC also has requirements for grounding and bonding. Grounding is the process of connecting electrical equipment to the earth. Bonding is the process of connecting different metal parts of electrical equipment together. Grounding and bonding help to protect people from electric shock. They also help to prevent fires. Proper grounding and bonding is essential for electrical safety. Another consideration is the inrush current of the AC unit. This is the instantaneous current drawn by the unit when it is first turned on. It is much higher than the running current and can cause a voltage dip in the electrical system. This voltage dip can cause lights to dim. The inrush current can be reduced by using a soft starter or a variable frequency drive. A soft starter gradually increases the voltage to the motor, which reduces the inrush current. A variable frequency drive controls the speed of the motor, which also reduces the inrush current. Harmonics can also be a problem in electrical systems. Harmonics are currents or voltages with frequencies that are multiples of the fundamental frequency. Harmonics can be caused by nonlinear loads such as electronic devices and some types of lighting. Harmonics can cause a variety of problems including overheating of equipment, malfunction of equipment, and increased energy consumption. Harmonics can be reduced by using harmonic filters. Harmonic filters are devices that block or reduce the flow of harmonic currents. It is important to consult with a qualified electrician to determine the best way to address harmonics in an electrical system. Surge protection is also important for electrical systems. Surges are transient overvoltages that can damage electrical equipment. Surges can be caused by lightning, switching of electrical equipment, and other events. Surge protection devices, or SPDs, are devices that protect electrical equipment from surges. SPDs are typically installed at the service entrance and at the point of use. It is important to select SPDs that are properly rated for the electrical system. Regular maintenance of the electrical system is important to ensure its safe and reliable operation. Maintenance should include inspecting wiring, connections, and equipment for damage or wear. It should also include testing the operation of circuit breakers and other protective devices. Regular maintenance can help to prevent electrical problems and extend the life of the electrical system. Lighting controls can also affect the electrical system. Lighting controls can be used to turn lights on and off, dim lights, and control the color of lights. Lighting controls can be manual or automatic. Automatic lighting controls can be programmed to turn lights on and off at certain times or to respond to occupancy sensors. Lighting controls can help to save energy and improve the comfort of building occupants. Different types of lighting have different characteristics. Incandescent lights are the oldest type of electric light. They are relatively inexpensive, but they are also very inefficient. Fluorescent lights are more efficient than incandescent lights. They are commonly used in offices and other commercial buildings. Light-emitting diodes, or LEDs, are the most efficient type of electric light. They are becoming increasingly popular for both residential and commercial applications. Different types of lighting have different color temperatures. Color temperature is a measure of the warmth or coolness of light. It is measured in Kelvin. Incandescent lights have a warm color temperature, while fluorescent lights have a cooler color temperature. LED are available in a wide range of color temperatures. The choice of lighting type and color temperature depends on the application. Emergency lighting is required in many buildings. Emergency lighting provides illumination in the event of a power outage. Emergency lighting is typically powered by a battery backup system. Emergency lighting must meet certain requirements, such as providing a minimum level of illumination and operating for a certain period of time. The NEC specifies the requirements for emergency lighting. The electrical system is a complex and important part of any building. It is important to understand the basics of electrical systems and to have a qualified electrician perform any electrical work. Regular maintenance and inspections can help to ensure the safe and reliable operation of the electrical system. Understanding electrical codes is essential for safe electrical practices. The NEC is the most widely used electrical code in the United States. It is updated every 3 years. The NEC covers a wide range of electrical topics, including wiring, grounding, overcurrent protection, and equipment installation. It is important for electricians and other electrical professionals to be familiar with the NEC. Building codes also contain electrical requirements. Building codes are adopted and enforced by state and local governments. Building codes cover a wide range of topics, including fire safety, structural safety, and energy conservation. Building codes often reference the NEC for electrical requirements. The electrical system is a critical component of any building, ensuring the safe and reliable distribution of power for lighting, appliances, and equipment. A well-designed and maintained electrical system is essential for the comfort, safety, and productivity of building occupants.